Let's work out a projectile motion problem. The problem I have in mind is from your homework. I want to make sure that we have all the numbers correct so you can get some real practice. So problem says a diver jumps off and comes down into the water. So let's set our picture correctly. Diver starts from here, so I'm going to call this y0. And this is final level. Y final is the level of the water. So I'll say this is y equal to 0 level. So in this case, the diver starts at a higher point, come down at a lower point. But it's a projectile motion. As the diver goes up and down, the diver is also moving forward away from its starting launching position to the right. What is given? Initial height is given to be 2.82 meters. 2.82 meters. And the next thing we know is given that the body enters the water, making an angle 70.2 degrees with the water. But right away, that's in the word. But we know that's a minus 70.2. That means it's really in Kappa language, 360 minus 70 minus 0.2 is the angle for this final velocity. So final velocity, it has to be measured, direction has to be measured from positive x direction counterclockwise to the vector. All right. What do they tell us about this velocity there? Well, we already have the angle. The value is given to be 8.62 meter per second. Okay, so how do they give us the final velocity? In polar components. 8.62 meter per second and minus 70.2 degrees. So magnitude and direction, that's given. So it would be good for us right away for the development of this problem to also figure out what is the component notation, how much is the VF in the x direction and the y direction. So by calling this coordinates to be x, I'm saying this is or this y, so y this way, x that way. So this is our coordinate system, and I'm choosing my origin to be 0 right here. So this is y0, x0. So as time goes on, object starts y0 at 2.8 plus 2.82 meters, goes up, then comes down, y becomes 0. All this time, x is remaining positive until the motion stops here. So they give us a V final, and I'm going to right away say I'm marking V final is given, angle, and magnitude. What do they ask? They ask, what is V0? V0 equals what is the question. So I'm drawing the problem. Problem didn't have a drawing in the on Kappa. I set my coordinate up, drew all this myself, so I want to visualize this problem. And also marking what is given, what's being asked. Let me point out here, in this problem, they didn't give us any time. So we'll have to figure out a way of solving for V0 without needing information about time. All right, I'm going to come there. But what has happened? What has happened is y final equal to yt equals 0. Y0 was 2.82 meters. So I'll say delta y clearly is y final minus y initial equals 0 minus 2.82 meters. So y0 is minus 2.82 meters. This, from the given fact, I already know. Object has fallen 2.82 meters. Do I know how much is delta x? I don't know. Okay, to figure out delta x, delta x would be Vx times t. I don't know the t yet. I can write Vx, since this is horizontal motion, is uniform, that means no acceleration. So I can even write this as V0x times t. I can find V0x right away, and I'm going to come and find that shortly. What else do we know? We know that acceleration vector A equal, I'm going to write two ways. Let me write in component form first. Component form would be 0 in the x direction minus 9.8 in the j direction. So many meter per second square. So A vector has only y component. In magnitude and component notation, in polar coordinates, it'd be 9.8 meter per second square. Still talking about A, but now polar. And coming down, vertically down means going around to 70, theta A equal to 270 degrees. So acceleration vector for a projectile motion could be said as AX is 0 and AY is minus 9.8 meter per second square, or it could be said, in polar form, magnitude is 9.8 meter per second, and angle is 270 degrees with the x direction. Okay, so I'm just setting this up. These are the things we know. These are the things we know. Now come here. This is a given. VF is given. So I want to find out what is Vx. So V at final time Tx equals Vf times cosine theta. So let's calculate these. Okay, maybe I'm gonna piece of paper here, a bigger paper. Let's do. So we know vector Vf making an angle minus 70.2 degrees. Vf is given to be 8.62 meter per second. We want to find x and y component. This is x, Vx. This is Vy. Vx at t, final point, time, equals magnitude V, 8.62 times cosine of minus 70.2. This comes out to be 2.92 meter per second. Why meter per second? Because this quantity is meter per second. What about Vy final? Vyt, t is my final instance, is equal to, once again, 8.62, same formula, except this time is sine of minus 70.2, and this number comes out to be, I think I can, yes, I did that, so I don't take time, minus 8.11 meter per second. So coming back here, from the polar description of the final velocity, 8.62 meter per second, making an angle 70.2 degrees with the water. I get object is moving at 2.92 meter per second in the forward x direction, and it's coming down minus 8.2 meter per second in the y direction. So I can also, since this is x component of motion, and we know for a projectile motion A sub x is 0, we know this is also the Vx at time t equal to 0, because acceleration is 0, velocity has remained same in the x direction. That's not true in this case. Okay, all right. So let's recap. What do we got? We got set up our picture.